Hi guys, and welcome back to our last lesson in our volumes topic. Today we are looking at packing algorithms. So again, this is just another way that we can be asked to package our different items. There are two different methods we're going to look at today. We have the first fit algorithm, which means that we take the items to be packed in the order that we've been given and we just fit them into the first available container. So that could be a box, a shelf, anything like that. The first fit decreasing algorithm is very similar, but the first thing we have to do is sort our items into decreasing size. So we start with the biggest, work our way down to the smallest, and then we apply that first fit algorithm. So we fit them into the first available shelf. So we are looking at bins or boxes that have a size of 12. We are going to use both of the algorithms to see how many bins we require for the following objects. So you can see here that I've got a list 1, 2, 4, 1, 11, 5, 6, 8, 3, 8. And we need to do the first fit algorithm first. So I'm just going to keep the objects in the order that they're in. In the first bin then, I could put in object 1, then number 2, and that's us at 3. If we add on 4, we're then going up to 7, plus 1 is 8. I can't fit 11 or 5 or 6 or 8, but I can fit 3, and that gets us to 11, which is as big as we can go because any more would take us over our max of 12. So again, I'm just going to tick off the ones that we've done there. Into bin number 2 then, I can fit number 11. I can't fit 5, 6, 8 or 8 though, so again our size is 11. Into bin number 3, I've got number 5 and number 6. I can't fit 8 or 8 though, so that's me done at 11. Number 4 then, I've got number 8. And then bin number 5, I've got 8 as well. And that's us. So 5 bins is the number of bins that we require. So really our final answer there is 5 bins is the total number of bins that we need to package our objects there. Using the first fit decreasing algorithm, the first thing we need to do is put them into size order. So starting with the biggest, I've got 11. I've then got 8 and 8. I've then got 6 and 5, 4, 3, 2, and then 2 ones. First fit decreasing then. Bin number 1, I'm going to start with number 11. So we've got that one ticked off. And then I can't fit 8, 6, 5, 4, 3, 2, but I can fit one extra one in. So that's going to give me the size of 12 when I add 1 and 11 together. So that bin is full. Bin number 2 then, I can fit in 8, so that's going to leave me with 4 left to get up to 12. So I can put 4 in and that gets us to the size of 12. Bin number 3, we can put 8 in, and then 3 and 1, and that gets us to 12. Number 4 then, we've got 6 and 5, and that gets us to 11. And then bin number 5, we've got just 2 left, so that is actually the same. So we would need 5 bins if we did the first fit decreasing algorithm, but we can see here that it's slightly more effective because we are filling the bins up to the max that we can. In our last example, we didn't have any that went up to 12. 11 was the highest that we got just from the order that we were giving them in. So the first fit decreasing and the first fit algorithm can give you different answers each time. Here we have got an example where we are delivering boxes using this van. Our only issue with our box is that the depth is different on each of the 13 boxes that we have to load. We are putting them into the van as shown. And what we need to do is either use the first fit algorithm or our first fit decreasing algorithm to work out what is the best order to pack these vans into. Now, I would perhaps look at this question and think, oh, am I going to have to do like our previous lesson where we were doing the maximum number of boxes we can fit in? But if we have a look here, the box in the same orientation that it's in, so my width of 1 metre and the width of 70 are going to match up, because if I have a look, C is 110 centimetres, and we should remember that 1 metre is 100 centimetres, so there is no way that we could fit the box in widthways. Again, we want all the boxes to be the same sort of orientation, it's just going to depend on its width, so we need to be careful. So my 70 is going to go against my 1 metre. My height as well, the 60 is going to go against my 1 metre, 1.1 metre here. So my variable then is going to go with my 1.6. So what we're saying here is that our maximum depth of boxes can be 1.6 metres or 160 centimetres. So in our last example, it was a size of 12. This time we're going up to 160. To give myself a wee bit more room, I have just copied over the information that we were given. And we know that our maximum depth, just to remind us, was 160 centimetres. So for load number 1, I am going to put in box A, which was 50. We can put in box B, which is 30. So we're at 80. I then couldn't put in C because that's more than the 80 centimetres that we've got left. So I can put in box D, which is 70. So that's us up at 150. None of my boxes are 10. So that is our maximum. So we're done there, and I'm just going to tick those off as I go. For load number 2, I'm going to put in box C, which was 110. That's leaving me with 50 left over, so I can put in box H, because remember we're just doing it in the order, so H is the first box that's under 40. H is the first box that's under 50. We've not got any that are 10 centimetres, so 150 is our maximum depth, so that's us done there. Then for load number 3, I'm going to put in box E and box F. That's 140 centimetres. I've got none that are 20 centimetres. So that is our maximum load there. Number 4 then, I can put in box G, which was 75. So that is going to leave me with 85 that I can still put in. So I could put in I, leaving me with 35 left over. So I can put M in this load as well. And that gives me 155. Load number 5 then, I can put in J with 90. I can then put in K that is 60, and that gets me to 150. And so my final load number 6 is going to be load L, which was just 50 centimetres. So here we can see that we would need 6 loads to transport all of these 13 boxes. If we use our first fit decreasing algorithm though, we can sort them into our size order. So remember, we always start with our biggest first. So that was C with 110. Then we've got J is 90. F was 80. G was 75. D is 70. Then we've got E is 60, as is K. A is 50. I is 50. L is 50. H was 40. And then B and M are both 30. And And I've got 13 letters there, so I know that I haven't missed any out. We're just going to work through the same thing as before. So load number 1, I can fit box C in, which was our 110. So I've got 50 left over, because remember 160 was our max that we wanted to get to. So if I've used up C, I can then go and find A, which was 50, and that takes me to the max. Number 2 then, J is 90, so I've got 70 left over, so we can package D in with that. 90 and 70 makes 160. Load number 3 is 80, so I've got 80 left over, so we could then fit in G, which was 75, and that's 155. Load number 4 then, I can have E and K, because 60 and 60 is 120. That means that we've got 40 left over, so I can have H as well, and that gives me 160. Then load number 5, we've got I and L, it makes 100, and E and M. So 50 and 50 plus 30 plus 30 is 160. So you can see here that we don't even need our last box. This time 5 loads was the maximum. So for this example, the first fit decreasing algorithm is actually better for us. We can fit more into less loads. I want you to use your knowledge from these examples to attempt the questions today. So question 1 here is very like the very first example that we did. So you're just using your first fit algorithm this time. So just that one way to sort these 6 different collections. For number 2, you are using the first fit decreasing algorithm to sort these ones. And then I've got 2 extension questions for you to try that are more like the second example that I did. You can use a calculator again for this example, although some of you will probably find that you won't need to. This content is new to everybody, so some of us have maybe seen last lesson before, but no one has probably seen our first fit or first fit decreasing algorithms. So I understand that we are going to maybe find this a wee bit more challenging. Make sure to use Teams or my email to get in contact if we need a hand with any of the examples, and I will see you in our next lesson.